So this is PN532 Programming Part 3. Before watching this video, please watch the previous videos. In this video, I'll be using NTAG 213, 215 and 216 tags. And I'll be showing you different command frames like the normal frames, the ACK frame, the NACK frame, extended frame. We're also going to see the command called in-data-exchange command and in-communicate through command. We have covered all these concepts in the previous videos, but in this video I'm going to discuss that in detail. You can see here I've connected my PN532 board to a USB to TTL cable, and this is the software we have been using on all my previous videos. So I have introduced a new screen here called the command prompt. So this is what we'll be using in this video. Now using this screen we can learn how to create the frames, and we can also understand the response from the PN532 as well as the command structure going from our PC to PN532. So I'm going to use a few commands here. So I'm going to, the very first command we have to use is called as a SAM config command, and if you look at the user manual it will be 14 and 01. I'm just going to quickly show you this command structure just once so that I don't have to repeat this again and again. Now this is the documentation of the PN532 user manual, and this is the command structure of the SAM configuration command. And we know that the first byte D4, this indicates the direction of the command. D4 means the command from the PC to PN532, and D5 means is the command from PN532 to the PC. So I'm not going to use this D4 because internally my program always adds D4. So I'll be using the rest of the commands. So this is the command followed by the parameters. So here, so if you look at and if you read this documentation, you'll come to know that before you use PN532 you must send this SAM config command, that is 14 followed by the mode. I'm not using any secure access module, it's just a normal mode. So I need just 14 followed by the 01. So since it is the very first command, and I mentioned this in the previous videos, the first thing we have to do, the software has to do, is wake up or sync the PN532. So I'm going to introduce a very long sync bytes. Again, the documentation says the sync bytes must start with the 55. I have got 2 5s, but this is not a problem at all. So when you hit this button, the prepare frame, so internally the program generates these bytes, and followed by, this is the structure of the normal frame, and the documentation clearly explains the normal frame, and you can see that the 1401 is embedded here, which is again it has got a D4, and we know that the 03 is the length, followed by FD is the length checksum, and finally we have got the prefix, the 000F. These are all the prefixes. These are, you can call this as a header, and the last 2 bytes, the last 17 is the again a checksum for the data, and this is the post number. So I'm not going to speak anything more about this structure from this point onwards. So we'll be just focusing on the commands. So I'm going to hit this. When I hit this button, send command, this entire bytes is sent to PN532, and you're going to see what will be the outcome. So we know that the first response from PN532 is the ACK frame, this acknowledgement frame. So this is a very fixed format, and when you program you can always check, you can define this as a constant and check the first 6 bytes, and all command that are sent to PN532 will always will always come with this as the very first response. So this is the actual response, and this is the processed response from PN532. Again, this also follows the normal frame structure. So we'll be interested in the length. Probably when you do the programming, you just have to check the fourth byte, and this will tell you how many bytes of response is present in this output. So 0 2 followed by the checksum, we can ignore this, and this is the response. And in this response the first part is always d5. Again, d5 is a direction, so this packet is coming from PN532 to the host, followed by 1.5, and this again depends on the command you send. So for all this information you have to keep looking at the documentation. So if you look at here for SAM configuration, the documentation is so clean, says it is d5 and 1.5. So I'm going to try some more commands here. I'm going to clear this. I'm going to try this command called setting the maximum retries. This is also one of the RF configuration command, and which is also present in this documentation. So I mentioned this, go to 66 and look for, I think it's RS configuration, or probably it is so this is the command 32, and because this same command can change more than one type of configuration, so each configuration type is given a code as well. So I'll be interested in the changing the maximum, the retries, which is item 5. Again, the documentation says the first 2 bytes must be all FFFs for normal operation, and 0 2 is the maximum retries I want to do. So I don't have to send these wake up bytes again. I can remove that. So this is the information command or information frame which you're going to send it to PN532, and you can see here we got acknowledgement followed by the response, and again the document says this is a positive response. So after that I'm going to try a command to select and activate a tag. So I'm going to use a tag 213. So this is a sticker, and we know that 4a is this enlist. 4a, this enlist think the target enlist passive target command, which is the command used for activating the tags. So let's quickly have a look at that. It is page number 115. Now this is a very like a complex command. So I'll be using the type A tags, which the document says it has to be 0 0. The maximum tag I would like to activate is 1, and keep in mind you can operate with the 2 tags, and 2 is the maximum number of tags PN532 can handle, and the remaining bytes it all depends on the other information, like you have to read the documentation here. So this command should activate. The first step is to prepare and send, and again we got acknowledgement followed by, and this is the output of the activation command. And I know that this up to here 01 means one tag has been detected. Actually this 01 is one tag detected, and this is the information about the tag, and we have seen this couple of times in the previous videos. And this response will also have the UID, which is a 7 byte, and this number 07 or tells the size of the UID. So it's pretty straightforward. The next is if you look at this, probably I'll try one more. I'm going to read the address 0, and one of the most important command, and which is also a very lengthier command. Length in the sense the number of pages in the documentation is the in data exchange. So go to 66, look for in data exchange, that is page number 127. Now this is the most important command because it is using this command PN532 will be communicating with the tag. So PN532, if you want to send a command to PN5 a tag, you use this command, and this command will also produce some response, and that's the response which is returned to our program. And again there is a lot of information here. This output, which is 40, the output will be 41. Status 00 is always a success, followed by some output. And you have to keep one thing in mind. This is the next explanation over here. And this command, okay, handles all the protocol details, depending on the type of the tag. So if you just have a quick walkthrough here, if you are using a MIFA tag, that's what the tag we are using. So the structure of the frame is like this way: the start of the frame, all the payload, and end of the frame. If you are using a Topaz, and every byte in Topaz will have its own frame, and that is what it is here. If you are using the IS4 14434, for example, a MIFARE DESFire tag, the structure is something different. If you're using a Felica, this is the frame. So all these internal framing is handled by the firmware which is inside the PN532. And if you're using a MIFARE card, and you can see that these are the commands I can use with in data exchange. So I'm going to use this command 30, and again the documentation explains what should be the parameters for 30. And if you go back here, so I'm going to use 40, that is, so the way you use this command in data exchange command is the 40 followed by the logical tag number. This is the number returned by the in list, which is a 0. 1 is for the first tag. If two tags are activated, you will have 1 and 2, and this is the data out. So the data out is where we put the MIFARE commands. So 4001 is more or less is fixed because we are using only one tag. So everything, all the commands and parameters should go in this data out. So here I'm using this data command 30 followed by the 00. So I know that 30 means read 16 bytes and 00 means it is block 0. So I'm going to send, and you can see that you get this as output, and I know that this is the right output because so this the block 0, see it's a 16 bytes reading. So what we have mentioned here is the page number 0, but the output is page 0, page 1, page 2 and page 3. So all these 4 bytes, 4 pages or 16 bytes of data is written, and you can see that you have to compare this with the information frame. So likewise, what will happen if I give a, if you have to use this in data exchange with the MIFARE tag, all your commands must be either this for a MIFARE tag, or if you are using say for example an ISO type of tag like 14434 is ISO tag, you can send these ISO commands as well. And if you are using, say for example, a Felica, you can use this Felica commands. And if you are using a Topaz tag, you can use all these Topaz commands. So you cannot send any command which is not listed in this documentation. However, let's give a try and see what's going to happen. So I'm going to try, say 95 something, send 10. Okay, so first thing is to prepare, and then I'm going to send. Okay, so we have received an acknowledgement frame, because every time PN532 gets a command from the host, it will always acknowledge it. Afterwards, we received an error frame. So if you go to the documentation, I always search this called preamble. So if you go to the documentation, where you see the structure of various frames. So let's go here. So this is the NAK on this error frame. So the documentation mentions here, this is the frame sent out by the PN532 when it detects an error at the application level. The application level here means the firmware. So we have sent a command which the firmware doesn't understand, so we received this error frame. And also you don't get any more information here, and this is like a fixed error frame. Probably now there's one more command which probably I'm not ready to show you that now, where you can get some more information about the error. However, so every response you get from PN532, you can check the first 8 bytes. If it matches this pattern, it is a error frame. So here we just received an error frame, and after that, if you try to, let us try to read again. So let's go see what's going to happen. So clear. So you know that there is an error. PN532 has gone to the error state. If you try to send this command again, oh yeah, so it has recovered. I never knew that it has recovered from the error. Okay, so probably the application error, because you have the word called application, probably that command has still not reached the tag. So you know that if a tag receives any wrong command, it will reset back to the idle state. However, this is a very good sign for us. So application error doesn't, you don't have to reactivate the tag. So there's one more thing, interesting thing. If you look at the documentation again, there are two more, because this video is mainly about these frames. I'm not going to come back to these frames in any of my future videos. The ACK frame, what this is an optional frame, and this is part of the handshake. The host can send this frame to tell PN532 that it has received the response. Again, this is an optional thing. So the next is the NACK frame. Again, this frame is sent out by the host. So this is telling the PN532 to resend the previous response. So again, it's mentioned very well here. So let us try this NACK, and I'm going to clear out. I'm going to send this NAK, and this is the command. So this is sent. See, there is no framing required when you send this command. You have to keep in mind. So you shouldn't ever do that. Put it there and enclose that. Also, there's an error as well. So I don't know what's the error. So also probably it is supposed to be a comma separated. So because this itself is a frame on its own, you do not have to embed this in the information frame. So you should never be doing like this. Okay, you just have to send this ACK frame. Sorry, we did NAK frame, and you can see here. So when this NAK frame is sent out to PN532, we immediately got the command we used just before that. That is the read address 0 command. So I've never tried these commands before, but however, so now I've just we have just witnessed that what this NACK command does. So likewise, I'm also going to try. Let us try to. You don't have to. Again, I'm reactivating. So clear. So I just have to take out this error message. So if you send an acknowledge, So when you send this acknowledge, you don't get any replies from PN532. However, in my entire program, I have not used ACK or NACK, and this is just for our knowledge. So now you know what is NACK and ACK. The next and the most important command I'm going to discuss is called the in communicate through command, which is in page number 136. And this command is so important. Without this command, you can never use like a Desfire or some of the commands of Entac 213 or a Topaz or this SRIX 4K. And this command, what it means is, any command which is not handled by the in data exchange command can be sent to the tag using this in communication through. I think this word itself tells us we are bypassing the firmware. So whatever you want to send directly to the tag, you can send it through this command, and the structure is 42 followed by the data out, which is the raw data. So you can put anything, any command, you can put it here, and the firmware is not going to check what you put. Everything will be sent as it is to the tag, and any response from the tag is filled in the response frame with the status either 00 or this. Okay, I'm going to try this. Is a very interesting command. If you have seen my videos on NTAG 213, 215 or 216, I have spoken about this command so many times, and this is the command which we can use to identify what type of NTAG command is it, whether it's a 213, 215 or 216. So let's not worry about the command structure in this video, and our main objective here is how do we send this command. And get version gives out, and this is the command structure. The command code is 60, and that's all. Everything CRC and everything is computed by the PN532, and the response is a 8-byte. So if I go to my software and if I try to this command is already, the tag is activated, but let's activate this again. Prepare. So activated. So we know I'm going to use this in communicate through command, which is a 42 followed by, not before that, probably try sending this command using the in data exchange. So I'm just going to copy paste the read, and I'm going to put 60 frame, prepare a frame, send, and we got a NAK because 60 is not understood by the firmware, and we got an application error. So I'll start using this application error. It's very interesting wording as well. So instead of that, this time I'm going to use in communicate through command, and I'm going to pass the command 60, which we know that 42 followed by 60, which is the get version command. So you still have to prepare a frame, and I'm going to hit this send command. Look at that. So we just got the output of this get version command. This is so important. Probably with this knowledge you can start using any command from any of these supported NTACs with PN532. You just have to go to the documentation, see the command, and just use the in communicate through command. I'm going to try one more, which we have got something called, there is a command to read the signature. It's called the versionality check. So let's try that. It's called read signature. So the command structure is, so we're not been as a developer, I don't think this diagram and timings, we don't have to worry that much. Here the command structure is 3C followed by 00. So I have to send 2 bytes and the output will be 32 bytes. So let's give it a try. So it is 3C followed by 00, and look at that, we just received the entire signature from Ack 213. So that is the purpose of this in communication through command. In a similar fashion, if you want to use like the password authentication, you know that Ack 213, which I myself have used this Ack 213 in so many event on conferencing, event tags, because the reason is this has got a password, and as a developer I can also configure the tag so that it automatically logs if somebody tries to uh, enter or guess the password. And I think Tag 213 is also very popular among many printer devices, and you can also like read commands. See, all these commands, if you want to try out, you'll end up using in communication through. So what I'm going to do next is, I'm going to show you the working of some of these, or mostly all these commands, using a Tag 213 and using my software. So I'm going to close this, we don't need that. So I'm going to connect properly and choose this Tag 213 screen, and this is the screen. If you already have my software, I have made a lot of changes to the screen, and I'm going to make a separate video and about how to use this, but in this video I'm just going to show you how I have used these commands, this in communication through command, to access some of the Tag 213. So I'm going to activate. So you can see that a lot of all these commands which have been showing here. So read the tag. So I can this I've been playing with this tag, so I already got, I hope I remember the password here. So I already got all these pages from 4 onwards. It is write protected. I'm going to clear this screen, and if you look at here, even in my software, if you click on get version, I have used the same in communication through command. Only thing, I'm decoding that into a nice grid. And get ECC, again I've just showed you this command using that console screen. And if I go to the password, so this is one of the changes I've done. So I'm sure the password probably is, let me guess, okay, otherwise I might have to use a new tag. So the password is ABCD. I'm going to authenticate. Oh no, it's wrong password, sorry for that. So let's reactivate and read again. So I think it must be 100. Authenticate. Oh sorry, so I think I better use a new tag. I'm sorry for that. So I have got a new tag, Tag 213, and in a new tag we still don't know what the password is, and we have to set the password. I'm going to activate and read. I'm going to change the password first. Again, okay, changing the password is probably, it's no different from a simple write. I'm going to change the password to decimal 1000. You can see what's the hexadecimal here. Yeah, decimal 1000. I'm going to write. Okay, so my password is now 1000, and here this again there's nothing different. We are just still using the same write tag, and I'm going to also change the configuration so that everything from page number 4 is password protected. So for that you need to change the authentication required, or before that, yeah, authentication required is from 4 onwards. Okay, so now everything is password protected. Probably I will also change the pack value to 1000 as well. Okay, now whenever we change the configuration, this the is going to effective only after we reset or reactivate the tag. So you can do a number of ways. I just got this RF on and off, so you can do that. Say RF off, so RF is gone. Again RF on, so I can reactivate. Okay, now I'm going to write to a protected page, so I can, yeah, so write it, say use a simple writing A B C D. So I'm going to write, but we have seen this one, I don't know whether this is a kind of undocumented feature. So we are trying to write without password authentication. Probably if I try to read, I get an error message, because we have seen this for some reason, I'm not sure. When you try to write to a password protected page, the response will be success. After that, when you try to read, you get error message. So this proves that it's not possible to write. So I'm going to select again, not this, take 213 to reactivate, and I'm going to clear, and this time we are going to use the password authenticate command. I can read because reading is not protected yet. So I'm going to authenticate. You got the authentication. Okay, let's see what has happened here. So I have used the in communicate through command by passing all the command structure which is required by the NTAG 213. So if you look at the password command, you have to use this command 1B followed by the 4 bytes of password, and what you get is a 2 bytes the pack value. So it's exactly what we have done. It is 1B, so followed by the 4 bytes of password. This is a lower byte, and what we get is the 2 bytes of pack value, which the pack value was also 1000. So this is very cool here, because communication through command is also easy, at least now. So you can, using this knowledge, probably you can access, try out all the commands. So thanks for watching. So you can buy this software, and I got so many other things, which is this mainly built for the developers and the students, and you can see here, and also got a entire kit which comes with the PN532 and cable and so many tags. And if you already have all these components with you, you can just look for this software, and all the screens I've you just saw in the video are also available here. So you can just, if you're interested, please buy this. It's really worth buying.